Let us see some of the problems on reduction formula, which are quite interesting and very important. Okay, let us see a reduction formula for sine. Okay, so if I consider uh, integral uh, integral of sine power n x dx. Okay, so let us consider this problem and arrive to the general form for this. Okay, now we have that as when you are looking into and trying to understand these concepts. So let us see that. Okay, now if I consider this as in, okay, integral form this. Okay, let me consider that as in here. Okay, okay. Now let us form the general form for this. Okay. Now if I call this as in, now let me write in minus 1. Okay, x, okay, into uh, sine x. I can write this. What I've done is multiplied and divided by sine. So I get back the same one which is there. So this is in, right? Dx. Now let us use integration by parts here. Uh, that is, if I integrate it, so I get this is sine n minus 1 x, integration of sine becomes minus cos x. Okay, this is minus. Now differentiation of this becomes n minus 1. This is sine to the power of n minus 2 x, and differentiation of this would be cos x. Okay, and integration of sine becomes minus cos x, and this is dx. Okay, so that's that. Now let us try to simplify this further. If I take minus outside, so minus this, so this is sine n minus 1 into x, and this is cos x. Okay, so if I take minus outside, so this becomes plus integral is n minus 1. Okay, this is sine n minus 2 into x. Now this is cos square x. So cos square x I can write as 1 minus sine square x and dx. Fine. I hope you understood this. What I've done. Cos square I have put as 1 minus sine square x. Now if I multiply this throughout, so I'll have this is minus sine n minus 1 into x. This is cos x, and I'll multiply that. So I get this as n minus 1. This will be integral. I'll have sine n minus 2 x dx here, the first place. So this is minus of now I can, if you look at the powers, that is n minus 2 and plus 2. So I'll get only power n. So this will be n minus 1, okay, minus integral. This is sine n x dx. So this is done. Right? Now let us write in terms of in and all those things. So this is minus sine n minus 1 into x. This is cos x, and this will be n minus 1, and what I said is I n minus 2. This is minus n minus 1 into I n. This is for in. Now further, if I try to simplify this further, okay, if I take to the other side, so I'll get in n minus 1, and this is plus 1. So in, I'll be having in here. Now in the denominator I'll have n here. So that would lead to minus of sine n minus 1 x cos x divided by n. Okay, plus I'll have n minus 1 divided by n, and this will be a minus 2. So I got the term which is required. Okay, and this is for IN reduction formula. Now let us further try to solve. If I have the limits as 0 to pi by 2, let us try to solve that. Okay. Because if I have 0 to pi by 2 as the limits, okay, let us try to solve that. So consider this as in, which is 0 to pi by 2. Okay, let us try to solve this now. Okay. Okay, let us try to solve this now. How do we do it? We know that in is minus of uh, sine n minus 1 x, okay, uh, into cos x. We have got this result earlier, plus n minus 1 divided by n I n minus 2. We got this earlier, this result earlier. Okay. Now for the limits which I put for this 0 and pi by 2. Why I'm considering here not there, because this is uh, you have I n minus 2, so I'll be applying limit only for this. Okay, so when I put this here, for cos pi by 2 is 0, as well as sine 0 is also 0. Okay, so I'll be having only in as n minus 1 divided by n I n minus 2. So this is the reduction formula. Okay, Now further to form this uh, to get in minus 2, in minus 4, in minus 6 and so on. So let's try to find that. So suppose if I have in minus 2 for n as n minus 2. So this would be n minus 3. Okay, this will be n minus 3. And that divides by n minus 2. So I got n minus 4. Now I want n minus 4. So I get this as n minus 5 divided by n minus 4. And this will be n minus 6. Likewise, n minus 6. Okay, n minus 6. So this is n minus 7 divided by n minus 6. And this is n minus 8. And so on. Let us further look how we progress about this in getting the result here. Okay, so let us see that. Now, when we proceed like this at the end of the result, so if I have to calculate I3, okay, so that would be 2 by 3 I1. So here n is odd here. If I want I2, so that would be 1 by 2 I0. Okay. Now let us put all the results which we got as of now. Okay. Now what I was talking about. Okay. So that would be suppose if I have to put that would be in. Okay. I am putting all the results which I have as of now. In n minus 1 divided by n minus 2. So n minus 2 we had that result. So I'll put that result here. So that is n minus 3 divided by n minus 2. So that would be n minus 4. Okay, n minus 2 I have put that result. So again I have this result. Let us put that n minus 1, n minus 3. This would be n minus 5. This is divided by n minus 2, and this is n minus 4. This is n minus 6. Okay, that keeps on going. Now we have these two results, that is n minus 1, n minus 3, n minus 5. Okay, this is divided by n. This is n minus 2, and this is n minus 4. Okay, and the last result which we get is 2 by 3 by 1 when n is odd. Okay, now I have this result again here, n minus 1 into n minus 3 into n minus 5. Okay, n minus 4 multiplied throughout, and this would be half times of naught when n is even. when n is even. Okay, and now let us find what is I1 and I0 here. Okay, here I1 would be, when I substitute that the general form, I1 would be integral 0 to pi by 2. This would be sine x dx. Integration of sine x is minus cos x, 0 to pi by 2. When we try to simplify this, we get 1 as the result. So what we got as I1 as 1. And let us find what is I0. I0 is integral of 0 to pi by 2 and dx. So I get this result as pi by 2. So let us put these results here. Uh, so so that I get In as this. Okay. So I got I1 as result 1. So when n is odd, and I0 as pi by 2. So this is for when n is even. Okay. Okay. Let us try to uh, solve some of the problems related to sine here. Okay. Okay. Let me try to solve this some of the problems here. Okay. Uh, Now let us find integral sine power 5 x dx. Let's try to solve this. Okay, by using reduction formula here. Okay, so this would be I 5 against 5. This is 5. So we have the formula here uh, that we have already discussed. If you look into that formula, let us look into the formula what we had. So let us write it down. So we have, by substituting that value, so that would be I5, which is minus 1 by 5 sine power 4 x cos x plus 4 by 5 by 3. Now we have to find what is I3 also here. Again, I3 would be minus 1 by 3 sin square x cos x plus 2 by 3 I1. So I1 would be just integral of sin x dx. Okay. So when we try to simplify this, I get this result as 1 by 15. I have cos x common here throughout because the integration of sin x is cos x. So I can take cos x outside. Okay, so multiplied with you have 3 sine power 4x plus 4, you have sine square x plus 8. So this is final result, which is okay. Let us look into another problem. Okay, so by using reduction formula. Yeah. Okay, let us look into that. Now suppose if I have integral of 0 to pi sine power 4 x dx. Let us try to solve this. Okay. Now this can be written as 0 to pi by 2 sine power 4 x dx plus integral 0 to pi by 2. This would be sine power 4. This will be pi minus x. Okay. Let's try to solve this. Here. Now since it's the same, so I can put 2 times 0 to pi by 2. So it's sine power 4 x dx. Now I'll be using the formula which I have said. Now here, if you look at this, so n being even, n is even here. That is 4. N is 4, which is even here. So 2 multiplied by, and this is 4 minus 1, which is 3, and 4 minus 2, which is 2 here, and it is again multiplied with 1 by 2, and also it is even, so it is pi by 2 here. So this results to 3 by 8 into pi, which is the solution. Okay, let us take a break and we'll come back again in 10 minutes.